All right, chemistry class. For those of you who missed Zoom this morning, it's too late to get the bonus for Who Am I? But I do want to go over some tips on how to solve mass to mass questions, all right? Number 21 for your homework, they're all mass to mass, so they're all going to follow the same 3 conversions, and we're going to go over them really quick. If you go to page 240, you're going to see where I'm getting some of this from. You're going to set up the 3 conversions like this. You're going to go grams to mole, mole to mole, and then go backwards, mole to grams. All right, so you do that pretty fast, right? Grams to mole, mole to mole, mole to grams, right? Grams to mole, mole to mole, mole to grams. So the next thing we want to do once we have that set up is we want to write in our substance. The first thing we put in is grams of what? Grams of what it's asking. Letter C says, I'm looking at it here, if you start with 1 gram of manganese oxide, right? Then it asks, how many grams of chlorine will be produced? So we're going from manganese oxide. So I'm going to put that in the middle one, manganese oxide to moles of chlorine, because that's the middle step is where I'm going to change from one substance to the other. All right, so I'm going to put that there, and I'm going to put in the other substances. I need a little bit more room here. Manganese oxide to 1 mole of manganese oxide, mole to mole. Moles of chlorine, now I'm changing the substance to grams of chlorine, all right? But now we still have to put the numbers in front, all right? So grams to mole, mole to mole, mole to grams, okay? Substance change in the middle step, okay? What about this step here? We need a number for manganese oxide. We're going to use the molar mass from our periodic table. How about the numbers here? This is going to come from our reaction. How about when we go from moles to grams? That comes from the periodic table. All right, so then we can go back and fill in the numbers. Grams of manganese oxide, manganese, I don't remember what that is. Let's see here, 54.94. 2 oxygen is 32. So we have 86.94 grams of manganese oxide for every mole of manganese oxide. That's the molar mass from the periodic table. Let's do the other one from the periodic table. Well, chlorine is 35.45. Do you remember there? 35.45 grams times 2. So Cl2 is 70.9 grams. So 70.9 grams in a mole. So again, we've got moles to grams to moles, moles to moles, moles to grams. Periodic table, molar mass. The middle part we said comes from the reaction. So look up here at the reaction. Let's go across. We're looking for manganese oxide. Oh, here it is. There's no coefficient in front of it, so we'll put the number 1 there. Then we're going across the reaction and looking for chlorine. Chlorine has no coefficient, so that's 1. All right, so we've got grams to moles, moles to moles, moles to grams. We've got our molar mass periodic table, our coefficients from a reaction, our molar mass from the periodic table, multiply across, divide by what's on the bottom. Now, when you get your answer, the question that was asked this morning is how many significant digits will you put your answer in? So significant digits question, all right, significant digits comes from what was measured. There's a lot of numbers here, okay? And what I'd like you to do is just continue to put your molar mass to 2 decimal places. That'll be enough. This one is 1.0. So the first one is 2 significant digits. All right. So if you get 0.83 0.59, whatever, it would be 0.86. You would round up. All right, 2 significant digits because it's 1.0. These aren't significant digits. These are just conversion factors. We don't worry about any of that. None of that was measured. All right, let's take a look at letter D and do it real quick. All right, you will need to figure out the answer on your own. But letter D threw some people off because it says how many grams of sodium chloride must react to produce 1 gram of chlorine. The number they're giving you is 1.00 grams of chlorine, and that's a product, right? But it's asking about a reactant. That doesn't really matter. It could give you one product and ask about another product. It can give you a reactant and ask about another reactant, or vice versa. Doesn't matter what it's asking you to convert to in the equation. You just write down the number and then you go through the same process. Grams to mole, mole to mole, mole to grams. All right, then we go back and we're going to put the substances in. Chlorine, chlorine. Middle substance, or the middle part, is where we go from one substance to the other. So it's giving you chlorine, asking about sodium chloride, moles to grams. Well, we are now talking about chlorine, all right? So here we have grams to moles, moles to moles, moles to grams. Where are we going to find the numbers? Again, periodic table, reaction. All right, 70.9 for the chlorine. I messed up here. Did you guys, hopefully you caught that, right? I was thinking about the next step and I didn't pay attention. So this should be sodium chloride, all right, because I'm converting it to sodium chloride. So 35.45 for the chlorine, 22.99 for the sodium, 13, 14, 8, 58, okay, 58.44 grams in 1 mole, 70.9 grams in 1 mole. How about the middle part? Chlorine, all right, has no coefficient, that's a 1. Sodium chloride has a coefficient, so that is a 4. So we have several true statements. There's 70.9 grams of chlorine in a mole of chlorine. 1 mole of chlorine in this reaction is equivalent to 4 moles of sodium chloride. And another true statement, 1 mole of sodium chloride has a molar mass of 58.44 grams per mole. All right, so all these are truthful as long as everything cancels out. Units and substances, all right, unit and the substance must cancel out. Make sure you put units and substance and they all cancel out and you should be good. Multiply all the numbers. 1 times 4 times 58.44, then divide, hit the equal sign, then divide by 70.9. Now, how many significant digits in this one? Well, the measurement was 1.00, so the significant digits in this case are 3. All right, hope that helps, and I'm signing out. All right, may the force of God be with you today.